India has done it. It has become now the fourth country to land a spacecraft on the moon after the US and China and the former Soviet Union.
Chandrayaan-3's successful lunar landing was already historic, but it soon revealed something surprising. On August the 26th, 2023, ILSA, India's moonquake-detecting instrument aboard the Vikram lander, recorded an unusual movement on the moon. The seismic readings confirmed activity that wasn't human-made, leaving scientists intrigued. Could it have been a moonquake, hidden tectonic shifts beneath the lunar surface, or perhaps something even more mysterious? This unexpected detection has sparked curiosity and opened new questions about the moon's secrets, still waiting to be uncovered. The moment it all changed. For weeks after Chandrayaan-3 landed, operations ran smoothly. The Vikram lander and Pragyan rover quietly explored the rocky plains, sending back images of jagged ridges and powder-fine regolith. Then came August 26th, when the lander's seismic instrument, the Instrument for Lunar Seismic Activity, or ILSA, recorded something entirely out of the ordinary. At first, it seemed like a routine tremor. The moon is not geologically dead, and moonquakes have been documented by Apollo missions decades ago. But this was different. The pattern of vibrations was sharp, sudden, and followed by a faint, rhythmic oscillation, like something heavy shifting its weight in the dust. Scientists at ISRO expected to find a clear geological explanation, perhaps a micro-impact from a small meteorite or thermal stress fracturing beneath the surface. Instead, the tremor's signature looked almost mechanical. It had a repetitive cadence that natural events rarely produce. The signal lasted for a few seconds, faded, then returned minutes later, stronger. No camera captured the source directly, but Vikram's logs show subtle changes in shadow lines on the horizon during that period, as if something had moved and then stopped. Engineers debated whether it could have been the rover itself, but Pragyan's location and systems showed it was parked and inactive at the time. So, if it was not the rover, and it was not geological, what was it? That was the question that began to haunt the mission logs, and the moment Chandrayaan-3's story shifted from routine exploration to unsolved mystery.
Very first pictures are emerging from India's rover on Earth's satellite, the Chandrayaan-3.
Could it have been debris from past missions dislodged by temperature shifts? Or could it have been a buried rock breaking free? Or could it have been something else entirely, something unrecorded in any moon atlas? If this was just the first hint, the real story might still be buried under the regolith. The moonquake that wasn't. When scientists use the term moonquake, they are usually describing one of four types: deep quakes from tidal forces, shallow quakes from tectonic activity, quakes caused by meteor impacts, and thermal quakes from temperature swings. But the ILSA data from Chandrayaan-3 did not fit neatly into any of those categories. The waveforms were too precise, too abrupt, and too localized. It was as if the source of the vibration had a beginning and an end, dictated by an external force, rather than the slow decay of natural energy release. In the hours after the anomaly, engineers tried to replicate the pattern in lab simulations, feeding it through models of lunar rock density, subsurface layering, and seismic propagation. The match came back closer to the vibrations you would expect from a moving object of significant mass making intermittent contact with the ground. That meant, theoretically, it could have been caused by something dragging, hopping, or shifting across the surface. ISRO publicly released the data, framing it as an unexplained seismic event, rather than hinting at anything unusual. But privately, teams began reviewing past mission records. Apollo's seismometers had recorded strange, shallow moonquakes in the 1970s, some of which lasted over 10 minutes without a known cause. Those too had generated speculation about subsurface movement. Could Chandrayaan-3's detection be a smaller-scale version of something ongoing beneath the lunar crust? Or had the mission simply been in the right place at the right time to catch something passing nearby?
Crewed lunar missions, including plans to have the first woman and person of color on the moon's surface.
There were whispers, too, of older Soviet lunar missions having picked up mobile anomalies in seismic records, though no official confirmation exists. If that is true, then perhaps this event is not unique, just the first time it has been observed up close in the Moon's southern polar region. And if something is moving there, is it alive? Is it mechanical? Or is it something else entirely, something no human category yet describes? Shadows in the polar light. The southern polar region of the Moon is one of the most intriguing places in the solar system. Permanently shadowed craters hold ice that has likely been untouched for billions of years. These shadows are pitch black and cold enough to trap not just water, but possibly other frozen materials. The region where Chandrayaan-3 landed lies near one such shadow zone, and in the days surrounding the seismic anomaly, the lander's horizon images recorded something peculiar. In a sequence of frames taken before, during, and after the tremor, a small dark shape appears near the ridgeline in the distance. It is not a dust plume, because its outline is too defined. It is not a lens artifact, because it shifts position between frames in a way consistent with an object moving relative to the lander. The resolution is not high enough to determine its nature, but analysts noted its apparent upright profile. Naturally, there are mundane possibilities. It could have been a rock revealed by subtle changes in sunlight, or a trick of shadow and contrast. But paired with the seismic data, it becomes harder to dismiss outright. When geologists study planetary surfaces, they often rely on multiple data points. If seismic and optical anomalies occur at the same time, the odds of correlation increase dramatically.
From the lander onto the lunar surface, and the satellite has made history as it was the first to touch down on the South Pole.
Some have speculated that the object could be an errant piece of descent debris, shifting under temperature changes. Others imagine a chunk of ice breaking free from shadow and sliding downslope. But in the more speculative corners of lunar research, there are those who wonder if the Moon's pole hides something that occasionally stirs. Perhaps ancient hardware from an unrecorded mission. Perhaps even something that predates human exploration entirely. The southern pole's shadows have hidden their secrets for eons. Now, for the first time, something within them may have moved. The instruments that listen in the dark. ILSA, the Instrument for Lunar Seismic Activity, was never designed to capture headlines. It is a compact, MEMS-based sensor mounted on the Vikram lander, built to listen for the faintest tremors in the lunar surface. Its job was straightforward: measure natural seismicity, log meteorite impacts, and help scientists understand the mechanical properties of lunar regolith. But in the silence of the Moon, even small anomalies become impossible to ignore. The August 26th event did not just show up as a blip. It produced a waveform that repeated in a suspiciously structured way, as if the source had a rhythm. This intrigued engineers because the Moon is a place where seismic energy usually disperses quickly, leaving behind irregular, fading signatures. A patterned signal is rare, and when it does appear, it often points to either human activity or a highly specific physical process. Since there were no astronauts, and the rover was confirmed stationary, the team had to dig deeper. They began cross-referencing the timing of the event with temperature fluctuation logs, solar incidence angles, and even distant impact alerts from NASA's lunar monitoring systems. None of these showed anything out of the ordinary.
26th August, 3 days after the historic landing. The Instrument for Lunar Seismic Activity detected a potential moonquake.
And yet, the data persisted, clean, sharp, and oddly deliberate. Some compared it to the faint repeated taps of a hand against a wall, spaced just enough to be noticed. Of course, no hand could be tapping, but that metaphor captured the unsettling clarity of the signal. The Vikram lander had essentially overheard something in the lunar night that it could not identify. While ISRO's public statement remained cautious, describing the finding as a natural event under study, internal chatter among analysts hinted at fascination, not fear, but the kind of scientific curiosity that thrives on the unexplained. Because if there is one truth about exploration, it is that sometimes the most interesting discoveries are the ones you were not looking for at all. The Southern Highlands' forgotten past. The Moon's southern highlands are rugged, ancient, and largely unvisited. They bear the scars of impacts older than Earth's oldest mountains, and their surface is littered with debris from events so violent they reshaped entire basins. For centuries, This region has been hidden from direct human exploration, visible only through telescopes and orbiters. That isolation has fueled theories, some grounded in geology, others drifting into legend. One of the more persistent ideas is that the poles could act as cold storage for artifacts of the solar system's past. Anything that landed here could remain preserved for millions of years, shielded from sunlight and micrometeorite erosion. That means if any natural or artificial object ever came to rest near the southern pole, it could still be sitting there, untouched, waiting to be found. Chandrayaan-3's landing site sits just a few kilometers from such a permanently shadowed crater. In fact, during mission planning, scientists specifically chose this region to study how ice and dust interact in these extreme conditions. But by chance or by fate, they may have put their lander close enough to something else to detect it. Skeptics will say it is likely a piece of rock shifting downslope, or a patch of regolith settling after thermal expansion. These are entirely plausible explanations, but the moon's long, unbroken silence makes any sign of motion an irresistible subject for speculation. If there is one thing space history has shown, it is that the unexpected is often hiding just beyond the edge of our certainty. If the moon still has surprises in regions we have never walked, what might be waiting in the places where no probe has yet landed? Patterns beneath the dust. Data review after data review brought ISRO scientists back to one conclusion. The signal did not match any previously catalogued lunar seismic event. The repeating pattern was subtle, but it was there. 3 pulses, a pause, then 2 more. At first, this seemed like coincidence, but over the course of a single lunar day, fragments of the pattern appeared again. Faint, but similar. This repetition raises an interesting question. Could the source be cyclical in nature? On Earth, certain seismic patterns are linked to tides, wind, or mechanical systems. The Moon has no atmosphere, no oceans, and no active machinery beyond what humans brought there. So what could cause such deliberate-seeming intervals? One proposal is that subsurface ice deposits, when exposed to sunlight, can crack and shift in repeating bursts as trapped gases escape. This would be a geological explanation, rare but possible. Yet the precision of the intervals leaves room for other ideas, ones that cannot yet be ruled out without more data. In the realm of playful speculation, some imagine an ancient mechanical object, buried and dormant, stirring slightly under heat changes, not functioning, but shifting enough to be heard. There is no evidence to prove this, of course, but such imagery has a way of sticking in the public imagination, and perhaps that is part of the reason this story has spread so quickly online. It taps into a deep human fascination, the idea that in the most barren places, something might still be moving. Whether or not the truth is extraordinary, the signal remains one of the most intriguing bits of lunar data collected in years. And as ISRO continues to analyze it, the possibility of a repeat event hangs over the mission like a second, silent countdown. When the Moon speaks twice. On September the 4th, just days after the initial anomaly, ISRO's monitoring team saw something that made them sit up straighter in their chairs. Another seismic reading had registered on ILSA, not identical to the first, but hauntingly similar in its profile. The same odd rhythm was there, the same unusually clean waveform, the same faint sense that whatever was moving had done so before and might do so again. This second event was weaker, almost as if the source was further away or partially shielded. But in seismic science, even small consistencies are worth chasing. The team cross-referenced the timing with lunar orbital data from other agencies, searching for possible causes, passing debris, micro-impacts, or even vibrations from thermal cycling in lander components. Nothing lined up cleanly. The rover's instruments were powered down during the reading, removing one more possibility from the list. The timing of the events sparked speculation about a natural cycle. Could there be a subsurface feature that expands and contracts at certain lunar times, producing motion detectable at the surface? Could a buried ice pocket be shifting under seasonal solar exposure? These are not impossible ideas, but they are difficult to confirm without physically being there to dig and measure. The problem is that on the Moon, repeating seismic activity from the same approximate location is rare. Most moonquakes happen deep underground, triggered by gravitational tides from Earth or meteorite impacts. Surface-level activity that repeats, especially in a deliberate-seeming pattern, invites deeper questions. Scientists will always begin with the simplest explanation, but in the court of public imagination, simpler is not always more satisfying. And right now, the court of public imagination is fully in session. Whispers from the shadowed craters. Permanently shadowed regions at the lunar South Pole are among the coldest places in the solar system, with temperatures plunging below -200 degrees Celsius. In these frozen craters, sunlight never touches the ground. Ice can survive for billions of years, and any object can remain preserved indefinitely. This is part of the reason Chandrayaan-3's landing was so historic. It brought humanity closer to these alien vaults than ever before. Some lunar geologists have proposed that these shadowed craters act as gravity traps for micrometeorites and space debris. Anything drifting too close could spiral down and rest forever in the frigid darkness. If this is true, then over time, the Moon's poles could accumulate a museum's worth of untouched cosmic history. A fragment from Mars, a splinter of an asteroid, or even debris from early space missions could all be sitting there right now, hidden under layers of frozen dust. The strange seismic readings raise an irresistible possibility. What if something in one of these craters shifted? Movement in the shadows could be caused by collapsing ice shelves, tumbling boulders, or even small rock slides along crater walls. But because of the Moon's stillness, such an event would stand out like a gunshot in a library. For mission planners, the idea of seismic signals from the shadows is both thrilling and frustrating. Thrilling because it hints at active processes worth studying. Frustrating because without a rover physically entering those craters, something no mission has yet achieved, the source will remain hidden. The Moon, in this case, is speaking from behind a locked door. How rumors outran the rover. When ISRO released their cautious statement describing the seismic events as natural, the internet did what it always does. It filled in the blanks. Social media threads began piecing together old lunar anomalies with the new data, creating elaborate timelines of unexplained events. Some pointed to Apollo-era photos showing strange shadows. Others revived decades-old rumors about artificial structures on the far side of the Moon. Even though there is no evidence for anything artificial, these narratives thrive because they feed into an ancient human habit, turning the unknown into a story. In this case, the story has all the ingredients of a classic mystery: a remote location, a witness, the Vikram lander, and an unexplainable sign of movement. Add in the fact that the source cannot be visited or confirmed anytime soon, and you have the perfect recipe for endless speculation. ISRO scientists, to their credit, have not dismissed these public theories outright. They know that public interest in space exploration is partly fueled by mystery. While the official channels remain focused on the science, the unspoken truth is that a little intrigue does not hurt when you are trying to keep people invested in the next mission. After all, the more the world cares about what is on the Moon, the more likely it is that someone will fund the trip to go and find out. Waiting for the Moon to speak again. Now, the mission team finds themselves in a strange holding pattern. They have all the data from the first two events, they have ruled out the obvious causes, and they are ready for the next occurrence. The problem is that lunar seismic activity does not work on human schedules. Days or weeks may pass before ILSA hears anything else unusual. The Moon keeps its secrets on its own time. Still, preparations are underway. If another event occurs, ISRO will have protocols in place to immediately cross-check it with all other instruments on the lander and rover. They will also coordinate with international lunar monitoring systems to triangulate the signal's possible origin. Each new data point will either bring them closer to a mundane explanation or make the mystery deeper. And in science, both outcomes are victories, one for certainty, one for curiosity. For now, the Vikram lander sits quietly under the harsh lunar sun, its sensors listening to a world that almost never stirs. Somewhere in that quiet, something has moved, twice, Whether it moves again will decide how this chapter of lunar exploration is remembered, as a footnote in seismic research, or as the opening lines of a mystery that will draw us back to the moon sooner than planned. The Chandrayaan-3 mission was already a triumph of engineering and ambition, but with the unexpected seismic events, it has also become a reminder that the moon is not as still as it looks. Whether the source is geological, environmental, or something we have not yet imagined, one fact is certain: the story is not over. Somewhere out there, in the silence of the lunar South Pole, the moon might be getting ready to speak again. And when it does, you can be sure we will be listening. If you enjoyed diving into this lunar mystery, make sure you subscribe and turn on notifications so you never miss our next Deep Space Breakdown. Drop your thoughts in the comments. What do you think is moving on the moon?